physics, there are two types of particles. There are composite particles and there are elementary particles. The difference between these two types of particles is that composite particles are composed of smaller particles. You can break them down into smaller constituents. Those constituents being, if you break them down far enough, elementary particles. Elementary particles being the particles you cannot break down further. The particles that don't have constituents but are the constituents, if you know what that means.
Okay, so based on the Bohr atomic model, which subatomic particles have subconstituents?
The protons and the neutrons.
Okay.
The electrons within the atoms are the elementary particles, but the protons and neutrons are composed of these smaller particles called quarks.
Okay.
So there are two types of quarks that compose the atom, that compose the atomic nucleus. They're called up quarks and down quarks. Well, and explaining the different types of quarks, I should rather explain the standard model of particle physics, which actually has all of the elementary particles. Quarks being elementary particles. So you have fermions and bosons. Within the fermion group, you have quarks and leptons. Those are the two main families within the fermion group. So within the quark family, you have up quarks, down quarks. Those are the quarks that compose the nucleons, the neutrons and protons.
Yeah.
And aside from those, you have charm quarks, strange quarks, top quarks, and bottom quarks. So within the lepton family, you have electrons. You've heard of that before earlier, just a few seconds ago. So you have electrons, muons, and tau particles. But those particles have their own neutrino variations. So you have the electron neutrinos, the muon neutrinos, and the tau neutrinos. So there are four elementary forces that describe the universe. You have the gravitational force being more dominant in the microscopic world rather than in the subatomic world. But in the subatomic world, the other three forces better describe the subatomic world. So you have the weak nuclear force, the strong nuclear force, and the electromagnetic force. So the quarks interact with each other through the strong nuclear force. The neutrinos within the lepton family interact with each other and other matter through the weak nuclear force. And the electrons, muons, and tau particles interact all through the electromagnetic force.
Okay.
So I think I'm good with the fermion family, and should I move on to the boson family?
Yeah.
So you have two types of quarks, but there's only one of the groups of quarks one of the group of bosons has only one boson. You have gauge bosons and scalar bosons. So since the scalar bosons has only one boson, I'm just gonna include the bosons in one big boson family. So you have the photon, which a lot of people are familiar with as light, electromagnetic radiation. You have, along with the photon, you have gluons, you have Z bosons, W bosons, and you have Higgs bosons. Not to forget that there are two types of W bosons. There are W bosons with positive charge and there are negatively charged W bosons, but they have the same mass and the same properties, so they're just the same W boson.
Okay.
So along with that, you have the Higgs boson, which is a scalar boson. All of the particles that I explained that were all of the bosons aside from the Higgs bosons are the gauge bosons. So the photon that interacts, the photon interacts with the electromagnetic force. Actually, let me say this about bosons. Bosons and there's a difference between bosons and fermions. Fermions are the matter particles. These particles interact with each other through given forces, well, through the three forces that describe the quantum world. An exclusion of an exception of the gravitational force. The bosons are the carriers of these forces. What I mean by this is, and there are two theories in quantum mechanics and particle physics that describe this. Quantum electrodynamics and quantum chromodynamics. So basically, these fermions these fermions establish forces between each other by emitting and absorbing these bosons, the carrier particles. They carry the forces from particle to particle, and that's why they're called the carrier particles.
Okay.
So, how do they carry the forces? So, the bosons carry the forces by momentum. So when a boson is being exchanged between two particles, it's going back and forth, it's moving, and it thus has momentum. That momentum affects both of the particles as they're interacting with each other, and that's how what is created, that's how what we know as a force is established.